Why is binding a class instance method different from binding a class method? I was reading the Python docs and stumbled upon the following lines. It is also important to note that user-defined functions which are attributes of a class instance are not converted to bound methods. This only happens when the function is an attribute of the class. Please, someone explain what does that mean in plain English. I'm going to introduce some shorthand notation. Let user-defined functions be denoted by f. Let class instance be denoted by c while class denoted simply by c. Obviously? C equals c with some abuse of notation. Also, allow membership statements to be recast in simple set notation, e.g. user-defined functions which are attributes of a class instance, and shorthand is vf, f epsilon c, where v, for all, and where a is the shorthand for set of attributes, e.g. of a class or class instance, and epsilon denotes the set membership function. Also, the process of binding a function is described in shorthand by c.f_args or cf_args equals fc_args or fc_args, the former referring to an instance method call while the later referring to a class method call. Using the newly introduced shorthand notation, does the quote from the docs imply that vf, f epsilon c, cf_args equals fc_args is a true statement? Wow! Vf, f epsilon c, c.f_args equals fc_args is false?
Setting a user-defined method to be an attribute of class, the wrong way. Consider the following example: class A and function f. The function f is defined separately and not inside the class. Let's say you want to add function f to be an instance method for our object. Adding it, by setting f as an attribute, won't work. Because function f is not bound to the object a. That is why when calling a.f, it shall raise an error regarding the missing argument, if f has been bounded to a, that object a was the missing argument self. This part is what the docs referred at. It is also important to note that user-defined functions which are attributes of a class instance are not converted to bound methods. Of course, all this has not to happen if function f has been defined inside class a. That's what the following part from the docs states. This only happens when the function is an attribute of the class. Setting a user-defined method to be an attribute of class, the right way. To add function f to object a, you should use which bounds the user-defined method f to instance a.
When you create a method the usual way, it will be a bound method. It receives the instance as first argument, which we usually assign to self. If you take an ordinary function and add it to the class attributes, it will work the same way. The instance gets passed as first argument. It is a bound method. If, on the other side, you make the function an attribute of an instance of the class, it won't be a bound method equals it won't be passed the instance as first argument when called.
I don't think the fancy schmancy formal logic notation is helping here. However, to answer the question, what does user-defined functions which are attributes of a class instance are not converted to bound methods, this only happens when the function is an attribute of the class mean? A bound method is one which is dependent on the instance of the class as the first argument. It passes the instance as the first argument, which is used to access the variables and functions. In Python 3 and newer versions of Python, all functions in the class are by default bound methods. So, if you create a user-defined function as an attribute of a class instance, it is not automatically converted to a bound method. Class instance is just a Python way of saying what object or object instance means in other languages. For example, here hello class is the class, while hc is the class instance. Greet is a bound method, expecting at least a single parameter, called self by convention, which is automatically assigned the class instance when called, i.e. the value of self before printing, hello John, is the hc class instance. Now, if you try this. That works, although your IDE may object, but this doesn't work at all. It causes type error column greet underscore with underscore high missing one required positional argument column name. And it should, because .greet on an instance of high class is not a bound method and the self greet underscore with underscore high expects won't be filled automatically.
I think the meaning is best clarified by way of example. Suppose that we have a class instance containing various attributes that are user-defined functions. Add1 was added by defining it as part of the class definition. Add2 was added by monkey patching the class before instantiation. Add3 was added by monkey patching the class after instantiation. Add4 was added by monkey patching the instance after instantiation. We try calling these. The first three all work. In the case of add3, it doesn't even matter that it wasn't an attribute of the class at the time of instantiation. Note that when we call these, we do not explicitly pass anything corresponding to the first positional argument inside the function, i.e. self. It is added automatically for us. This is what is meant by it being a bound method. It is declared with one positional argument and we are explicitly passing none at all. But in the case of add4, it is complaining about missing positional argument. This is because the instance is not automatically added as a first argument. It would work if you used explicitly 2.add4 too.